Okay, so welcome to yet another video of my series on statistics. And in this video, I'm going to introduce you to measures of dispersion. But before then, if you have not subscribed, kindly subscribe, kindly comment, like, and share. Okay, and a prerequisite to this video is the first video on the series of measures of central tendency and dispersion. So if you have not watched it, kindly watch it, and this video will make more meaning to you. Now, in this video, before we go to the measures of dispersion, I want to comment quickly on some other measures of description. Now, remember that when we are computing median, median is more or less like the middle position, okay? The middle position of the set of figures. Now, sometimes for decision-making purposes, when somebody picks a set of data, the person may not be interested in the middle position. So if you have a set of figure like this is the middle, and this is the quarter position, this is the middle. 2/4 is the same as 1/2. And this may be the 3/4 position, right? You have a set of data like this. The middle is the median. Now, for decision-making purposes, somebody may also want to know the position between the beginning and then the middle. And that position is called the quarter position or the 25th percentile position. Remember, median is the 50th percentile position, all right? So for decision-making purpose, somebody may want to also know that between the first figure and then between the figure in the first position and between the figure in the middle position, between those two figures, what is in their middle? Okay, so the figure or the position in between the first figure and then the middle position is what we call the 25th percentile or the quarter position. Then also somebody may also want to know that between the middle position and then the last position, what figure lies in the middle of them exactly? Okay, so the figure that lies in the middle of the middle figure position and the last position is what we call the 3/4 position or the 75th percentile. The 3/4 position or the 75th percentile. Okay, so in essence, the quarter position is called the first quartile. The median itself, which is the middle position of the whole set of figures, is called the second quartile or the 50th percentile. Then the 3/4 position is called the third quartile or the 75th percentile. Okay, now how do we calculate percentiles? We have to sort the data in either ascending or descending order, then determine the percentile location, all right? Determine the percentile location. Determine the percentile location, okay? So if the set of figures is 8, the number of figures is 8, and you are looking for the 25th percentile or the quarter position of the figure. So let's say we have 1, 2, 3, 4, 5, 6, 7, 8. The number of figures here are 8. All right. So if I want to know, okay, there's an example here. So let me not go ahead of myself. So if I want to know the position of the 25th quartile, is just 25/100 times the 8. There are 8 figures. All right. That's 25% of 8. You know the position, okay, of the 25th quartile. Let's look at this example. In this example, the figures there are 19 figures, and they have been arranged in either ascending or descending order. So this has been arranged in ascending order. So for instance, if I'm looking for something like 60th percentile, it will be 60/100 times the 19 figures, I'll get 11.4. Okay, I'll get 11.4. 11.4, usually when that's the 11.4th position. Now, when you get something like this, you have to round to the nearest whole number. So technically, this will be the 12th position, okay? This will be the 12th position. So the 12th position, you count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this is the 12th position. So for this data, the 60th percentile is 82. We can also find the 25th percentile. 25th percentile will be 25 over 100 times the 19 figures, okay? So that means that you find 25% of 19. When you punch your calculator, 25% of 19 is around, 25% of 19 is 4.75. So that is, if you round it, that is the 5th position, all right? The 5th position would have been 1, 2, 3, 4, 5. So the figure 51 is the 25th percentile, okay? You can use the same idea to find 75th percentile, 50th percentile, 90th percentile, whatever position you want to find in terms of percentiles or quartiles. Okay, so this was the example I gave. All right, so the first quartile or the 25th percentile is like 51, like how I was showing you earlier. All right, you get 51. Now, we can represent these quartiles, the major quartiles. So listen, the major quartiles are Q1, that's the first quartile, the second quartile, and the third quartile. These are the major quartiles. That is the 25th percentiles, 50th percentile, and then 75th percentile. Now, what I want you to know is that, you see, we can represent these quartiles on a graph, okay? And the representation of these quartiles on the graph, that graph is called the box and whisker plot, okay? That graph is called the box and whisker plot. So let's look at how we do the box and whisker plot. Now, for the box and whisker, the first point is that you have to sort the values from highest to lowest, and of course, find your Q1, Q2, Q3, okay? Now, we draw a box so that the ends of the box are at Q1 and Q3. Then draw a vertical line through the median, that is Q2. Then calculate the interquartile range, extend the dashes from each end to the highest and the lowest values within the limit, and identify the outliers and asterisks. So let's look at this example. The set of figures are 0, 2, 2, 2, 3, 3, 4, 5, 6, 11, and 27. Now remember that in this set of figures, the figures are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the 25th percentile, so times 10, the 25th percentile will be 2.5 position. All right, so 2.5 position, if you round it, that would be the 3rd position. So the 3rd position is 1, 2, 3. All right, so this figure here is the figure in the first quartile. Now, if I want to find the 3rd quartile figure, we all know it is 75% of the 10 figures. And that will give us the 7.5th position, or technically the 8th position. So you count 1, 2, 3, 4, 5, 6, 7. So you count 1, 2, 3, 4, 5, 6, 7, 8. Okay. So this figure is in the 75th percentile, or what we call the 3rd quartile. Okay, the 3rd quartile. Then of course, if you use the same procedure to find the median, you are going to get 50% of the 10 figures, and that will be the 5th position. All right, that will be the 5th position. So that will be 1, 2, 3, 4. 1, 2, 3, 4, 5, which is here. And we count from here, 1, 2, 3, 4, 5, which is here. So these two figures, their middle is this one, right? So this is the median or the 50th percentile. Now, what I want you to notice is that the first step in drawing box and whisker is to find Q1, Q2, and Q3. So in a graph, the next step is that draw the box so that the ends are at Q1 and Q3. So when I have a graph, okay, X, Y, and X axis, okay, I'll draw the end of the box should be, so the end of this box should be, so the first quartile is 2. That's why the end of this box is at 2. Then the other end of this box is at 6 because 6 is the third quartile. Okay, so you draw a box where on a graph, the beginning of the box should be at the first quartile, the end of the box should be at the third quartile, as we've done here. Now, the next step is to draw a vertical line through the median. So you have to divide the box. So we have to divide the box, but we divide it at the median. So you find 3, the third point. This can be a graph, like where we have 0.0. If you have a graph like this, so here will be 0, 1, 2, 3, 4, 5, and then the 6, 7, 8, 9, 10, 11, and then 12. This can be a graph. So we now draw a vertical line through the median. So you have this. That is the second step. So that's the fourth step. The fifth step is that calculate the interquartile range. So interquartile range is Q3 minus Q1. Okay, so Q3 minus Q1 is the interquartile range. Because interquartile range is the third quartile figure minus the first quartile figure. It will give you the interquartile range. Okay, so that one will be 6 minus 2, which is what? 3. So the third step, we found the interquartile range. The fourth step is extend the dashed line from each end to the highest and the lowest values within the limit. Now, how do we compute the lower limit and then the upper limit of this graph? Okay, the lower limit is Q minus 1.5 times the interquartile range. So the lower limit is Q minus 1.5 times the interquartile range. Okay, so Q minus 1.5. The interquartile range is the lower limit is, sorry, Q1. All right, Q1 minus 1.5 times the interquartile range. So Q1 minus 1.5 times the interquartile range is 3. All right. So Q1 itself is 2. All right. Q1 itself is 2. So Q1 itself is 2 minus 1.5 times 3. So if you compute this, 1.5 times 3 is 4.5. 2 minus the answer, you're going to get minus 2.5. Pause. Yes. But you see, in these figures, there is no minus 2.5. So the graph would have come to the negative section of the graph. But you see, the lowest of these figures is 0. So once the lower limit is below the lowest of these figures, we cap it at the lowest of these figures. So our lower limit will be 0 because we can't use negative 2.5. The reason is that we can't go beyond even our minimum figure. So once it goes beyond or below that, you cap it at the minimum figure. Then the upper limit is Q3 plus 1.5 times the interquartile range. So Q3 plus 1.5 times the interquartile range. So the Q3 was 6 plus 1.5 times the interquartile range is 4. Sorry, let's make this correction. 6 minus 2 is 4. Okay, sorry about that. So the interquartile range is 4. Okay, so 1.5 times 4 will be 6. So 2 minus 6 would have been -4, right? Sorry about that. But of course, we can't go to -4 because we will cap it at 0. So that is it. Now, here will be 6 times 1.5 times the interquartile range, which is 4. So it will be 6 plus 6, and it is what? 12. So the upper limit is what? 12. The lower limit is 0 because we can't go below the 0 and choose -4. Then you extend the line from the box to the lower limit, and we also extend the line from the box to the upper limit. So now we will have our box and whisker graph. Now, the box and whisker is a graph that even tells us about the skewness. Okay, the box and whisker graph is also tells us about what? The skewness. Now, you see that the tail of this distribution is more towards the right than the left. The tail is more towards the right than the left. So we can confidently conclude that this distribution is right skewed because the tail is more towards right than the left. See, the left is very short, but the tail is more towards right than the left. So this is also right skewed. Now let's provide a summary of our descriptive statistics. So remember, mean is all the values summit divided by the number of items. And of course, remember in the video that I taught you about ratio or interval data, I mentioned that ratio and interval data, they are usually figures. So once they are figures, we can compute their mean. Okay, once they are figures, we can compute their mean. So whenever your data is ratio or interval, the best measure of central tendency is the mean, unless there is an extreme value. So the advantage of the mean is that it's the numerical center of the data. The summation of the deviation from the mean is 0, but the disadvantage, the mean is the numerical center of the data, but the sum of the deviations from the mean is 0. So this is not good. And then it is sensitive to extreme values. It's also a disadvantage. You explain why the sum of deviations from the mean is 0. We explain it subsequently in this video. Now, again, the median can be used for ratio or interval data, as in the median can be used for figures or data that is quantitative, as we demonstrated. But the median can also be used for qualitative data, all right? For qualitative data. For instance, if somebody is short, medium height, and tall, okay, these things are not figures, they are just qualities. But the middle of these three is the median, which is the medium. So this one becomes the median. So median can be used for even qualities and not necessarily figures. Once you can rank the qualities or you can order the qualities, you can pick the middle to represent the median, right? So median is not sensitive to extreme values. Median is computed only from the center value. So this is an advantage, but median does not use all information from the data because it will just rank and pick the middle. It's a disadvantage. That's why we say median is computed from the center values, all right? Then finally, mode. Now for mode, we can find mode for ratio or interval data, as in we can find mode for figures. We can also find mode for qualitative data. Like for instance, this data here, if I add medium again, okay, the mode in this set of data is medium because medium appears twice. But if I have data like 1, 2, 3, 3, and 6, the mode is still 3. So whether the data is ratio or interval, which is quantitative, or whether the data is ordinal or nominal, which is qualitative, we can still find the mode. But the mode may not reflect the center. For instance, if I have figures like 1, 2, 3, 3, 6, 6, 6, 7, 7, 7, 7, and 8. These figures, the mode is 7, but 7 is not really the center of this data if you check, all right? So mode may not reflect the center. Sometimes mode may not even exist. So if I have figures like 1, 2, 3, 4, and 5, there is no mode. And sometimes we can, so this is a disadvantage, and a disadvantage. Sometimes data can have multiple modes. Okay. So I did this video as a cursor or a precursor to the measures of variation, all right? So like, comment, share, and most importantly, subscribe. In the next video, I'm going to teach on the measures of dispersion or the measures of variation. Thank you.